background, other than radiocarbon dating, GIS is perhaps the most profound advancement in archaeology, in as far as the ability to interpret, analyze, map, and understand archaeological sites and patterns of movement and lifeways in the past. Obviously, ArcGIS, Esri products are a really powerful tool, and I use them. But QGIS is also quite powerful, and its interface in some ways is more intuitive to my taste than the Esri products, and it has the great benefit of being free. We at the Division for Historic Preservation are going to be rolling out shortly the revised guidelines for conducting archaeology in Vermont, and part of those guidelines will necessitate that archaeological consultants submit shapefiles at the end of their archaeological investigations. And we realize that while GIS is becoming increasingly important in project design and in development, in architectural review, it is an expensive cost for some people, and QGIS is a free alternative. So I've really tried to learn QGIS as much as possible for my own sake, so that when I say to consultants, you know, we'd like you to submit shapefiles, I'm not saying that you have to necessarily purchase expensive software, that there are these freeware alternatives. QGIS has a native Mac interface, which is great. In my own personal environment, I use Macs, so that's an advantage. And it's got a lot of interesting tools and third-party plugins. The downside of it is that there's no large database or educational repository for QGIS. You kind of have to figure things out on your own through web blogs, through forums, through YouTube videos. Thanks very much, Leslie. And so what I'm going to share to you today is a workflow that I needed to have, and I thought I would figure it out using QGIS. It ended up being quite an adventure, and I have to thank anonymous and nicknamed posters on places like GIS Stack Exchange and YouTube for being able to figure this out. So certainly much of this is cobbling together other people's research. Hang on.
Oh, underneath there.
Yeah. Oh, sorry.
You should, sorry. Hold on just a second, everyone. You should have a thing that allows you to say, yes, I'd like to show my screen on there somewhere.
Oh, gotcha.
I'm not sure where that went.
Right there. No.
Remember the little thing that pops up that says, is it okay to share your screen?
Yeah, it did that before. Just 1 second. I'm not able to share my screen.
Oh, no, there it is.
Okay. Okay.
Sorry about that.
So back to it. As part of our regulatory review in 2002, and based on an earlier model since 1989, we developed an environmental predictive model for discovering pre-contact archaeological sites. This isn't obviously to find sites that are already known. We know where those are, but it is a checklist that evaluates an archaeological site's proximity to a number of environmental and a few cultural features. And in 2002, when this was developed, it was based upon a long history of research, understanding Native American land use in the past through time, what humans in general needed to survive. But there was no way that it could be comprehensively tested against the overall universe of sites we had in Vermont. It was just too big prior to QGIS to really do that. So a lot of it was intuitive, logical, but intuitive. Now with the advent of QGIS, or GIS in general, and QGIS and what I'm doing, we have the ability to more comprehensively evaluate our scoring of archaeological sites' predictive proximity to environmental factors, and how that might inform in the future future iterations of this predictive model or allow us to refine it. So what you'll see here is the dots are quite big, and I'm sorry they're overlapping. The universe of known archaeological sites in Vermont related to pre-contact Native Americans. There's 2,220 of them, and we get new submissions every week from consultants or other researchers working in the field. So that number changes quite frequently, but when I made a snapshot of the shapefile, it was 2,220. Overall, this is of a universe of about 5,920 archaeological sites, the remainder being historic archaeological sites or underwater archaeological sites. So what we're looking at here is pre-contact Native American sites, because the predictive model ceases to use a lot of its predictive value once industrialization occurs and people are able to manipulate the landscape to the way they want. This really assumes quite rightly that Native Americans prior to industrialization had to map themselves onto landscape features rather than alter them. So we have these archaeological sites. And in statute, archaeological site locations are protected. And so I'm not going to use any geographic location tags underneath this elevation model, and I'm going to kind of keep it quite general. It won't affect any instruction that I'm going to give for the purposes of this webinar, but it just allows a little bit of anonymity of these locations, although you can probably figure out where in Vermont we are, certainly. So before we get into the actual methodology, it's important to set up your project to the coordinate system that you want to use, and in particular, it should be in a coordinate system whose measurements correspond to the measurement you ultimately want to use in your output. So if you want to use feet, you choose a coordinate system that's measured in feet. If you want to use meters, meters. In this case, archaeologists use the metric system, and VCGI has almost all of their shapefiles and other imagery preset to Vermont State Plain, so we're working in a united coordinate system. But you can see other webinars on how to make your project into a particular coordinate system, and also when you import shapefiles, they will then convert those on the fly. So we have an underlying elevation model, we have our archaeological sites, and what I wanted to do for the purposes of this exercise today is compare how close every one of those dots, which represents a pre-contact archaeological site, is to the nearest water body. So I downloaded VCGI's Vermont Hydro layer, and there is a field which I can show you if you go to the attribute table that says shape area. They pre-calculated that. I sorted out all of the lake pond water hydrological type and then segregated those out, so I'm not showing rivers or streams, but just isolated water bodies for the purposes of this exercise. So we'll get out of that. The first thing we want to do, and I can zoom in quite close here, is to take this vector shapefile, the water bodies, and turn it into a raster. Now a raster, Leslie and I just had a discussion earlier about this, whereas a vector file is sort of a bounded polygon, so you can see the rough boundary of each of these water bodies. A raster is like an image where each pixel is given a set value. And the first step we need to do is to change this vector file or shape file to a raster. In QGIS, you go to raster, conversion, and then raster, otherwise known as rasterize, otherwise known as vector to raster. And then we get this prompt. Now, the first thing you want to do is to make sure that the input file is the shape file you want to convert. So in this case, it's water bodies. The attribute field is the particular field that this rasterization is going to call upon to do it. So you want a field that has some measurement to it, either area or length. VCGI has thankfully already pre-populated, as I showed you, the attribute file with an area and length. We're going to choose area. And then in your output, just choose an area that you want, or a repository where you want your GeoTIFF raster to go. Now, I should warn you that the size of these files, and I'll get into this more in a second, is very large. So make sure you choose a repository that has enough space. And I would also say that I've had some trouble doing this onto external hard drives. That could just be an artifact of my particular system and setup, or this particular version of QGIS, which I should probably mention is 2.12.2 Leon, and it's currently up to version 2.18. So I'm not using the most recent one. I was afraid to update it in case something happened for the purpose of this webinar, although certainly it's a good idea in general to keep up with the latest versions. So just make sure that if you can, save it on your computer's own C or other internal drive. If not, try it on an external and make sure you have plenty of space. So just set a target for that. Here, then, we want to choose raster resolution and map units per pixel. Now, because I said our parent projection of this project is Vermont State Plane meters, each pixel, if we chose this right now, would be 1 meter squared per pixel. Now, I've made the mistake of trying to do this at a 1-to-1 scale, and I saw the raster size climb to around 100 gigs until my whole computer crashed. So your mileage may vary. If you're running a supercomputer, it probably would be fine, and if you have, terabytes of hard drive. But in more constrained environments, such as my laptop here, I had to choose a higher scale. Now, for my purposes, I did some trial and error with this. 5 square meters seem to be right. This gives you an error in any measurement that you're ultimately going to derive from this workflow of 5 square meters, but ultimately that was an acceptable error range for what I'm trying to do. Now, depending upon your workflow, you could be dealing in kilometers over a continent, or any other mileage, and so obviously this will have to vary depending upon how you want to use this for your particular task. But after you've set that, you press OK. Now, I should say that it's a known error that throws up where it'll then go back and say you haven't defined an output location. Just go back, hit select again, then you can go to OK. Now, I'm not going to press OK here because it takes usually about 20 minutes to generate this raster file, and even at this resolution, it ends up being about 16 gigs. So I'm not going to do that now for the sake of brevity, but I did do it a couple days ago, ran through it all, and at the end, it came out with this raster. So, and let me shut off water bodies. So when it originally came in, if you see over here in the table of contents, this said NaN and this said 1, and I saw nothing but black. If you went to the, if you go to the properties though, and click on the style tab over here, I just changed NaN to 0 and max to 1 and kept everything else the same. And at that point, the water bodies showed up. Water bodies being white and obviously everything else being black, which is fine for our purposes. And as I said, I chose a 5 square meter interval per pixel. And so as you can see here, as we zoom in, the image does get pixelated when you get very close. And just to do an approximate measurement here, when you go across, you can see it's roughly 5 meters per pixel. So that came out right. We have that built-in error range, but we acknowledge that. The next step is sort of enigmatic. Leslie and I were talking about this. We're not exactly sure what the ultimate output of this is, but it is to develop a proximity raster. And we're not exactly sure, but I'll show you the zoom out of what it does. But it's an interim step towards our ultimate goal anyway. And it's a particular tool that's inherent in QGIS. It's not a third-party plugin yet. So we go to Raster tab again, Analysis, and then Proximity, Raster Distance, in parentheses. Okay, here our input file will be Raster Water Body, which is the name of the raster I just generated in the previous step. Again, we just want to select an output location. And again, you can see I did it here. Again, all the previous caveats pertain here. In my particular case, it generates a raster file that's about 6 gigabytes. Again, it'll be different depending upon your purposes. But again, having it on your computer's hard drive seems to work better for me. Now here, the only other thing we have to choose here is distance units. We want geographic, which means it will calculate distance in reference to the project's projection. Again, that will be in meters. We go down, yes, you want to load onto the canvas when finished. You press OK. It crunches away again for another period of time, which I won't do, but again, I did this a couple days ago, so all of these steps did work. And then we come out with another raster file, which I will zoom out because it's best displayed at a wide view. And it looks like this. Again, not much to see. We're not exactly sure what's being calculated, whether it's the boundaries of particular items, and so it's measuring from boundary to boundary, but for our purposes, this is just a transitory step. And again, going back to then this stage. Now, so we have our raster prox. We want to make sure that this is clicked, and we want to make sure that our target, our location points file are checked in the table of contents before we go to our next step. Now, our next step is going to involve installing a third-party plugin. QGIS is great because it allows third-party plugins quite readily. People all over the world are generating them. Most of them are for free, and they do a variety of really wonderful things and quite specific things for specific fields, whether it's surveying or environment or archaeology or any of the other things. It's a really great repository. And to get to the plugins repository, you just go to Plugins tab, Manage and Install Plugins. And it should come up. Oh, it's coming up in my other screen. Hang on. And you come to this sort of repository. You can see what's installed, what's not installed out of the universe, and you can also search. So the plugin we're looking for here is Point Sampling, and ultimately it's Point Sampling Tool. We want to click that to install it. Mine's already installed, so I don't get the prompts. But once it's installed, get out of this, and you will have this plugin installed. The icon looks like this. We want to just hit it. Now, I should give a warning about plugins, much like QGIS itself. Plugins provide a lot of great functionality, but the background information, tutorials regarding plugins are often minimal to non-existent. And so again, you might have to do some hunting on web forums, tutorials, YouTube videos to figure out exactly how to do this step by step. This one in particular took me a while to track down how to actually execute it, but it ultimately ended up being quite easy. So what we want to define here is 2 fields that will ultimately end up being part of the shapefile that's generated. And again, we want to make sure that our proximity and our point file layer, shapefile layer, are highlighted or checked in the table of contents. That will then populate this series of fields. So what do we want from our point attribute table? I chose object ID because it's a unique identifier that the shapefile gives to every particular row or dot in your entire shapefile. In this case, it will give a unique identifier to every one of the 2,220 archaeological sites that are represented by them. And then we want to go down and click Control, so you can highlight one of the other ones, and do raster procs. So those two, did I not? Yep. So those two will be highlighted. Okay. Then all you want to do is browse again to an output layer. This file is quite small. It can go anywhere. If you've got a central file filled with particular shape files, it could go there. It is not large. We want it added to the table of contents layer after. You press OK, and again, let it run. It will run quite quickly. And then here we go. Now, what you'll notice and what should happen after is here's our archaeological site universe of sites. We can get rid of the raster procs, and then so we're back down to the elevation model. And the shapefile that's generated should mirror exactly the originating point layer, in this case archaeological sites. So it overlays one another perfectly, but if you go into the attribute table for this, you will see only two columns. One column is the object ID, which corresponds one-to-one with the designations in the archaeological site shapefile in this case, and then a distance. It'll say raster procs, but it's actually calculating a distance. So let me shrink this down a little bit, and we can choose just any one of these. Let's choose this one, and we want to go to, and oh no, we want to do this in the reverse. So let's go to, I will then turn on water bodies again. Let's go to, let's just say this one. Did I not select? Oh, I'm sorry. Yep, sorry, select. Choose this one. And then if we go to our attribute table and we go to bring it to the top, you will see that it's 380 meters to the nearest water body. Let's zoom in, and we'll use our measurement tool, and it's roughly 380 meters. Again, I'm not zooming in particularly well on this, but roughly 380 meters to the nearest water body. And it calculated that for every one of those 2,220 points, which is, fantastic for our purposes. Now, there are various third-party plugins that can export your attribute table at this point to a CSV file for use in Excel. I find the easiest way is just to highlight every one of them, copy to clipboard, and then export into Excel. So this isn't really an Excel tutorial, but just quickly, I did use the frequency function on Excel, and at the end of it, and then I, put together some of these nice graphs. And what you can see here is that I only took sites for the purposes of this graph that measured between 0 and 300 meters from any particular water body. The universe of those sites was 888. And then looked at the distributions. And so what can we see? We can see there's a very clear correlation between archaeological sites, about 50 of them immediately adjacent to water bodies. And then it drops off, and we see some peaks and valleys all the way through out to 300 meters. Now, when you calculate a trend line for that, you can see that there is a slightly decreasing trend line, which we would expect, although I have to say that this was one of those things that really opened my eyes when we ran this model, because it's not clearly as decreasing a trend as we might expect. Now, part of this is because water bodies are not universal throughout Vermont. They're sort of isolated in space, although they're quite frequent. and so they're not uniformly associated across the landscape. And so there's somewhat of an artifact in that, and this will require future research and analysis by us. Now, I went through, for the purposes of this exercise and for a beginning analysis of where we are with our predictive model currently, with analyses of other environmental features, including, in this case, rivers. Here we see a much more logical regressive trend where archaeological sites are obviously predominantly associated closer to rivers and then get less frequent farther away. There's also sort of a bimodal trend here a little bit where they seem to fall off at around 90 and then again at 180, although we'd have to do some more statistical analyses of that. Well, parenthetically, the universe of these archaeological sites, again, only choosing those ones from 0 to 300, was 759. Streams, not so much immediately adjacent to streams, but then following the normal trend, and this might be because stream, immediately adjacent to streams might not have been where those stream alignments would have been a few hundred years ago, or it might have been wet. Streams, unlike rivers, don't have the predominant banks. They might just be a subtle trend into the stream, so you want somewhere a little bit higher and drier. That's intuitive. I don't know that. Again, a subtle sort of bimodal trend around the 150 mark. And then finally, a combined one that I generated, which also has wetlands in here, and a very interesting spike in sites located immediately adjacent to wetlands. Again, we have to project back that the archaeological record goes back 13,000 years. And so the hydrology, the overall structure of the land might be different today than it certainly was 13 or 10 or 8,000 years ago. Wetlands in particular have been subject to some eutrophication or some creation. And the data set, it doesn't show natural versus artificially created wetlands. So certainly some of that will have to be teased out more. Likewise, water bodies will even show ponds created for cattle. All of that needs to be sorted out to have a more robust data set. But some of that gets washed away in the robustness of the 2,220 sites we're looking at. So again, just a starting point, but a really remarkable tool. And really will allow us to approach more systematically how our predictive model works today and how it might work better in the future. Although I have to say that by and large, the scores that our predictive model currently has seem to be borne out with a few specific caveats with these analyses. With that, I think that's it. I'd be happy to entertain any questions or any problems you might encounter now or in the future. And just want to thank Leslie and VCGI for allowing me to do this.
Great. Thank you very much, Jess. So everybody, this is your chance to send in questions for Jess, specific to the analysis he did, maybe other general questions about how he uses GIS in archaeology, anything
That's
about
a big one.
QGIS, anything you'd like to send in at this point. We're happy to do our best to address. Might take people a second.
No problem.
Do you, actually here's a question I have. Do you anticipate your paper format system that you have now evolving?
Into a GIS-based predictive model? Yes. That has actually been attempted in the past, but really back in 2007 when it was generated, and again, this just shows how fast the technology is improving. Mm-hmm. Back then, it didn't quite cut the mustard. Mm-hmm. For one thing, just a more pragmatic thing, it didn't reflect all of the categories in our predictive model. Mm-hmm. It reflected a sort of critical set of them, but without all the categories, it was sort of crippled. Mm-hmm. The other caveat is the next time we build the the GIS-based predictive model reflecting the paper-based predictive model. We do want it to be reflected exactly, but there's some things that currently there are no data sets for, like modern disturbance versus natural disturbance. Things like evaluating eutrophication. Excuse me. There are also things for which no shapefiles exist, like heads of draw of raylift drainages, things like that. So without going out and collecting that data ourselves, which is prohibitively expensive, we will have to figure those out. Now, LiDAR is making all of that become easier and easier because you can run, protocols that might highlight those minute environmental features, which before were beyond our grasp. And so it's, within the next year or two, we're really talking about rolling it out in earnest. It won't ever, or at least not in the foreseeable short to midterm, replace an actual walking out in the field visit, but it will be a more powerful tool to get you started.
Right. So we have a question. Have you considered a neural net instead of linear relationships to predict probability of archaeological sites?
I'm just starting to learn about neural network and network analysis. This is becoming a sort of a hot topic in archaeology. I just went last year, the 2015 Society for American Archaeology Conference in Orlando, and sat in on a whole symposium about using neural network analysis. I will say that I'm not so familiar with it. I more saw the products than the actual process, so I'm not sure how the process is implemented and iterated for us. But the products were very interesting. They were primarily using things with much more stuff, like great houses at Chaco Canyon and cliff palaces in the Mesa Verde region, and how they related to one another and trade and exchange. But I will never downplay the richness of the archaeological record here, or the understandings that are out there to be generated of hunter-gatherer lifeways over the millennia. So it just will take some sort of understanding of what the nodes are in those processes, and then how to roll it out. But yes, it's a great point. It's one of those things that I read at night and on the weekends, trying to get myself more up to speed on it.
Yeah. Okay, another question. How do you think the definition of sites on the ground affects these data, meaning sites as bounded entities versus particular find spots within a site?
Yes, this is really huge. This is why we are beginning to require that consultants submit shapefiles, because point data are not particularly great at understanding the universe of archaeological sites. Right now, a site that encompasses 10 acres gets the same value as a dot as a find spot that might be one or two projectile points on the ground. That is a serious impediment to what we're looking at. We understand it. Unfortunately, or not unfortunately, but the reality is we're building upon a paper-based record that has old paper-based maps. I am committed to eventually getting all of those digitized and rendered as shapefiles or equivalent, but it's a long haul. It's a tough row to hoe, and even starting from the present, we have to build back 40 years. There's only about 2 states in the Union that have done that so far, so we're certainly not an outlier, but all of us understand the need. And the more you understand both the size of archaeological sites, the density of artifacts in particular areas, the uses of particular sites, whether extractive, processing, habitation, ritual, the more nuanced this model will become. And that is one thing I'm acutely aware of, understand. But it's important in a regulatory context to at least establish some sort of baseline and predictability. And we will constantly be iterating towards better orders of perfection, but this is where we are, and yes, that's where we want to go to.
Okay. Let's see, another question. Oh, have you looked for differences by site age or type? Oh, I see differences.
Yes, and that's very interesting. This is another, this gets into another initiative of mine and the divisions that was recently completed, which is getting online and then mapped. That's actually how I was able to generate that point file, all of the reported archaeological sites in Vermont. Now, consultants, researchers have to fill out now it used to be a paper-based form, now it's an online form with various pull-down menus and everything. Once that's in, it's filled out with pertinent information, which then populates. We can sort that by time period, by site size, but there is some pollution in the data, and I use that in the nicest possible term, in the fact that knowledge has increased. So 30 years ago, what people called one thing, we now know is something different. Also, some of the early site files were done by collectors who had an imperfect understanding of what they were seeing, as did archaeologists. I mean, we are sitting atop the accumulated knowledge of 40, 50 plus years. And so at a certain point, we have to build back into that and cross-check and refine or change some of what they called that. Until we do that, we can get a general understanding. I've done maps that have all the late woodland, meaning from 1000 AD to the time of European contact sites in Vermont. But when you actually dive into what people are calling late woodland, I'd want a more robust understanding of that before I generated those maps, although we are starting to do that. And it's easier to go back in time and start from the beginning because there's so few of those Paleo-Indian sites, less than 30. There's only slightly more early archaic. And so that's really where we're starting, is to make those exactly on the same level, coincident and able to be correlated with one another, and then build up through time until we get ultimately to this 2,220.
And do you have enough information about all those other older pieces of data? Do you have enough either physical or documented information to make the search?
We do, otherwise they wouldn't be in this. There's a whole other universe of sites that sort of, quote unquote, don't make the cut, meaning we know something about them, there's third-hand accounts, they don't make that cut into this database. There has to be some critical mass of knowledge for us to put them into the database. Doesn't mean more information will come in the future in which it will get elevated, but that's where we are now.
Okay, another question says, I'm not familiar with Vermont's Ice Age coverage, but have you tried including ice coverage which varies by date with archaeological sites when predicting site probability?
Well, yes and no. This actually is something that I'm intimately familiar with. This is what I do a lot of my own personal scholarship on, is Paleo-Indians. So ice coverage, the last glacial maximum went down to roughly Long Island Sound, and then there was a slow retreat. The ice fully receded from Vermont, according to John Ridge and a few other geologists working in Vermont and New Hampshire, by about 13,400 calendar years ago. That is prior to any human occupation, not only in Vermont, but in the entire region. The earliest dates in the northeastern region are right around 13,000 calendar years ago. And I say calendar because radiocarbon ages differ by up to 2,000 years at this early time period from calendar ages. You have to calibrate them using tree ring data and lots of other things. So calendar years ago. The first Native Americans we call Paleo-Indians don't appear to enter into Vermont until about 12,700 years ago. So land cover or ice coverage is not pertinent. But the Champlain Sea, which was an inland arm of the Atlantic Ocean, was there in the Champlain Basin. Lake Hitchcock in the Connecticut River Valley may or may not have been there at the very earliest, and it would have only been coincident with perhaps the very earliest Paleo-Indians. That's still up for debate. But the Champlain Sea surely. And yes, we model Champlain Sea shorelines, and on my own, and then this will obviously contribute to the division's research, I'm working with a number of colleagues to refine the actual location of the maximum shorelines and then regressive shorelines of the Champlain Sea. And yes, my scholarship has pretty well indicated that Paleo-Indians preferred shorelines of the Champlain Sea for occupations. And what that implies is very interesting. Were they hunting whales and seals? Well, perhaps.
And The last question that I see here, I think, is have analyses of these type been done for negative data, sterile STPs?
That's another great question. Yes, so we are working in something of a tautology here, meaning that we have not mapped heretofore negative site areas. And this is another glaring hole in the data set. That's another reason why we're requiring shapefiles and going and building back all of the maps of negative site areas in the past. Because
negative site areas meaning
we've done
research
holes in the ground and didn't find anything. Yep, and that might really provide nuanced understanding of why we didn't find things there. Why, having worked for roughly 15 years in the field, doing archaeology from roughly April 1st to Christmas, I can tell you that on an intuitive level, many of these things bear out. But I'm sure that there are some nuanced things we're not picking up, likely related to change over time, and negative spaces could really fill that out. And that is something, again, unlike neural networks, which I don't have a great understanding, I have an acute understanding of the deficit of not understanding negative sampling has sort of built into this system, and we're going to work back out of that.
And again, you do have data.
We do, but again, it's paper-based for much of it.
Yeah.
So, I'm hoping consultants working with them over the next year or two will be able to go back in and not requiring them to do extra work, but at least give me whatever they had digitally from the first use of shapefiles, and then we can use that. That gives us about 10 years back. Before that, it's all paper, and that becomes more problematic. Geo Referencing Old Maps, a lot of work. As Leslie, who works with historic ortho photographs, can tell you, a lot of work in a work in progress, but one that I'm acutely aware of.
All right, that's the last question I see. So if anybody has any last-minute questions, now is your chance to send them in. We'll wait maybe another minute, and then we will probably wrap things up. Do you have any other comments you want to make about using QGIS or other types? I mean, we've talked about a bunch of different types of analysis you're interested in doing, but is there anything else?
Yeah, QGIS, I once again, I think it is not, some, real, bad alternative to Esri's products. I do appreciate Esri's products. In particular, I will say if there's one detriment to QGIS, and if there's QGIS people out there that know how to code, it could really do with an updating on its georeferencer. But other than that, I've found the functionality quite equivalent in a great many areas. And I'm quite happy to use it. It's on all my Macs at home, and it has served me well since I, made the jump to say, all right, if I'm going to be recommending this to people, I need to learn how to use it, and I've been rewarded for doing so.
I was just going to put up your page. Is your contact information on a archaeology page?
Yeah, I'm sure it is. Yeah.
Okay. Let's see if we have any other questions. All right, I think we are done with questions, so I am going to take back the screen very briefly just so that I can pop Jess's contact information up there. Okay. So this is the Agency of Commerce and Community Development website, and the Vermont Archaeological Inventory page, and down towards the bottom here we have Jess Robinson, State Archaeologist, as well as his colleagues Scott and Yvonne. So thank you very much, Jess. This was fascinating. It was really fun both to learn about archaeology and to learn about some QGIS analysis, which I need to learn more about. So I hope everyone found it useful. I appreciate it if you fill out the little survey that you will encounter as you leave the webinar. And remember, the webinars are, this webinar is being recorded, and it will be posted at VCGI's YouTube page, which you can get to with a link right here on our front page, or you can just look up VT Geospatial in YouTube, and all of our recorded webinars get posted here. Thanks again, Jess, and I hope everyone has a good day. Thanks.